Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the mass of excess reactant left over in a chemical reaction. So grab your periodic table of elements, grab that polyatomic ion list, and grab your scientific calculator, and let's work on an example problem. In this example problem, it says to calculate the mass of excess reactant left over from the reaction of 114 grams of copper 2 sulfate and 131 grams of silver chromate. So we have a reaction here where all we know are the two reactants that are reacting together. And what we're asked to figure out is the mass of the excess reactant that is left over after these two reactants react with one another. So the very first thing that we're going to have to do here is we're going to have to write a correct chemical reaction equation based off of the two reactants that are given in this problem. So if we take a look at this problem, we have two things that are reacting with one another. It looks like we have copper 2 sulfate and silver chromate. So in this problem here, we have copper 2 sulfate reacting with silver chromate. And what we have to do is we have to predict what the products of this chemical reaction are going to end up being. And then we have to write the correct chemical reaction equation. So let's go ahead and first figure out what the two products of this chemical reaction are going to end up being. So if we take a look, we have copper 2 sulfate. So copper 2 is Cu with a +2 charge. And if you take a look at that polyatomic ion list that just popped up in front of it, you can see that sulfate has a -2 charge. And since these two ionic charges add up to 0 already, we don't need to add any subscripts to these elements in this compound. So there's our copper 2 sulfate. This is going to react with silver. Silver forms a +1 charge. And chromate, if you take a look at that polyatomic ion list that just popped up in front of you, you'll see is CrO4 with a -2 charge. And since these two ionic charges don't add up to 0, we're going to have to place a 2 here so that they do. So we have Ag2CrO4 is our correct chemical formula for silver chromate. So now, what are the products of this chemical reaction going to end up being? Well, if we take a look here, we know that positives and negatives attract. And so what's going to end up happening is that this copper ion here is going to want to bond with this chromate ion, and this silver ion here is going to want to bond with this sulfate ion if we keep in mind that opposites attract. Opposite charges are going to be attracted to one another. So the two possible products of this chemical reaction are going to end up being copper 2 chromate. So copper 2 again is Cu+2, and chromate is CrO4 with a -2 charge. And since these two ionic charges add up to 0, we don't need to add any subscripts here. And what is our second product going to be? Well, it looks like it's going to be silver, which has a +1 charged ion, and sulfate for SO4 with a -2 charge. And since these two ionic charges don't add up to 0, we're going to need 2 silver ions so that they do. And so you'll notice here I put a 1. I didn't put a 1 here. You can write this as a +1 or just a plus sign. Either one of those will work when we're trying to write the correct chemical formulas for these compounds. And so what is our chemical reaction equation going to look like? Well, let's go ahead and write this without the ionic charges. We have copper 2 sulfate, or CuSO4, reacting with silver chromate, Ag2CrO4. And this is going to end up producing copper 2 chromate for CuCrO4 and silver sulfate, Ag2SO4. And so what we have to do now is we have to balance our chemical equation. This chemical equation right now, if we take a look, It might be unbalanced, it might be balanced, but we have to check to make sure. If we take a look right now, we have one copper on the left and one on the right. We have 1 sulfur on the left. We have 1 sulfur on the right. We have 4 oxygens here and 4 here, which makes 8 oxygens. We have 4 here and 4 here for 8 oxygens on the right. We have 2 silvers here. We have 2 silvers here. We have 1 chromium on the left and we have 1 chromium on the right. So it looks like our chemical equation is in fact balanced. So now that we know that our chemical equation is balanced, we can actually start the stoichiometry process. And if we take a look in this problem here, this is telling us that we have 114 grams of this stuff right here. It tells us here we have 114 grams of copper 2 sulfate and we have 131 grams of silver chromate. And so what we're asked to figure out is the mass of the excess reactant that is left over. So if we're asked to figure out the mass of the excess reactant that is left over, we first have to figure out which of these 2 reactants is going to run out first. That is to say, we have to figure out which of these 2 reactants here is the limiting reactant. And the way that we're going to do that is by arbitrarily picking one of these 2 products here to determine the mass of, based off these 2 quantities that we have right here. So let's go ahead and just figure out the mass of copper 2 chromate that can be produced. And so we have 114 grams, it looks like, of copper 2 sulfate, and we have 131 grams of copper 2 sulfate here, sorry, and we have 131 grams of silver chromate. So what we have to do now is use our stoichiometry to figure out the mass in grams of our copper 2 chromate. So the very first thing we're going to have to do here is cancel out grams of CuSO4 and figure out the number of moles of CuSO4. We're then going to have to cancel out moles of CuSO4 and figure out the number of moles of CuCrO4. We're then in our last step going to have to cancel out moles of CuCrO4 and figure out the number of grams of CuCrO4. So what goes in these empty spaces? Well, if we take a look, this step right here is our mole ratio. It looks like our mole ratio, because our chemical equation is already balanced and doesn't need any coefficients, is going to be 1 to 1. So now what we have to do is we have to figure out our molar mass of copper 2 sulfate. So let's go ahead and do that. Let's figure out the molar mass of our copper 2 sulfate. We take a look here, we have CuSO4. So CuSO4 is made up of copper. It's made up of, I'll tell you what, I'm going to leave us with more room here. So copper 2 sulfate is made up of copper. It's made up of sulfur and oxygen. We have 1 copper, we have 1 sulfur, and we have 4 oxygens. So we're going to take 1 times the molar mass of copper, which is 63.55. If we take a look on our periodic table of elements, this will give us 63.55. Sulfur, we'll take 1 times the molar mass of sulfur, which is 32.07. And I'm leaving the units off here. We'll attach those at the end. And oxygen, we have 4 times 16.00, the molar mass of 1 oxygen. That will leave us with 64.00. We add all of these together. We'll take 63.55 plus 32.07 plus 64, and the molar mass of this is 159.62 grams for every mole. So we just figured out the molar mass of this. 1 mole of CuSO4 is 159.62 grams. What about over here? Well, we have to figure out the molar mass of CuCrO4 now. So let's go ahead and do that. We'll try to find some room here. It looks like we're going to have some room down here to figure this out. Or maybe we'll just go ahead and do that right here. So we have Cu CrO4, we have copper, we have chromium, and we have oxygen. There's 1 copper, there's 1 chromium, and there's 4 oxygens. So we're going to take 1 times 63.55, and we get 63.55. We're going to take 1 times 52.00, and this is going to give us 52.00. And we're going to take 4 times the molar mass of oxygen, which on the periodic table is 16.00. And that's going to give us 64.00. So when we add these together, we're going to end up with 179.55. 179.55. So that is our molar mass of this stuff right here. So we know 1 mole of CuCrO4 is 179.55 grams. And when we put this in our calculator, we'll take 114, we'll divide this by 159.62, we'll then multiply by 179.55, and we're going to end up with 128 grams. So now we have to do this exact same process with our silver chromate here. So let's go ahead and start that process. So the very first thing we're going to have to do is cancel out grams of silver chromate. So we'll put that at the bottom. And figure out the number of moles of silver chromate. So we'll put that at the top. We're then going to have to cancel out moles of silver chromate. So we'll put that at the bottom, and we're going to figure out the number of moles of copper chromate, or copper 2 chromate, sorry, so we'll put that at the top. We're then going to cancel out moles of CuCrO4 and figure out the number of grams of CuCrO4. So if we take a look, our mole ratio here of copper 2 chromate to silver chromate from our balanced chemical equation, there's an imaginary 1 here, and there's an imaginary 1 here. If we take a look, we know that 1 mole of copper 2 chromate, we already figured that out, is 179.55 grams. So we're now going to have to figure out the molar mass of our silver chromate. And so let's go ahead and figure out the molar mass of our silver chromate. We're running out of room, but it looks like we'll have some room right here. If we have silver chromate, that's Ag2, CrO4, we can see that this is made up of silver, it's made up of chromium, and it's made up of oxygen. There are 2 silvers, 1 chromium, and 4 oxygens. So we'll take 2 times the molar mass of silver, which is 107.87. This is going to give us, let's see, 2 times 107.87, 215.74. We take 1 chromium, which is 1 times 52.00. That's going to give us 52.00. And we're going to take 4 times oxygen's molar mass from the periodic table, which is 16.00, and we'll get 64.00. And when we add all these up, we're running out of room, but we'll put this right here. We have 64.00 plus 52.00 plus 215.74, 331.74. So we just figured out the molar mass of this stuff here. The molar mass of our Ag2CrO4 is going to end up being 331.74. So let's go ahead and put this in our calculator. We'll take 131 divided by 331.74 times 179.55, and we're going to end up with 70.9. 70.9 what? Grams of CuCrO4. So if we take a look here, how much CuCrO4 can be produced? Is it this much or is it this much? Well, we're going to go with the lower of the 2 quantities. If you remember in our video on calculating limiting reactants. So 70.9 grams of copper 2 chromate can be produced. And which of the two is the limiting reactant? Well, it looks like our limiting reactant here is going to end up being this stuff right here, our Ag2CrO4. So this stuff right here is our limiting reactant. This is the stuff that's going to run out first in our chemical reaction. And if this runs out first, then this right here, our copper 2 sulfate, will be our excess reactant. So we just figured out the limiting reactant was this by doing this entire process, and so this must be our excess reactant. And what we're asked to figure out now is the mass of the excess reactant that is left over after these two quantities react with one another. So the way that we're going to have to do this is we're going to have to do one more little stoichiometry calculation. What we have to do is we have to take the initial mass of our limiting reactant and figure out the mass of our excess reactant that's consumed. So if we take a look, we're starting with 131 grams of Ag2CrO4, and what we're now going to have to do here is we're going to have to figure out the mass of the excess reactant that is consumed. So now we're going to use the 131 grams of silver chromate here to figure out how much of our excess reactant is consumed. So we're going to cancel out grams of silver chromate. We'll put that at the bottom. And we're going to figure out moles of silver chromate. So we'll put that at the top. We're then going to cancel out moles of silver chromate. And we're going to figure out moles of copper 2 sulfate after that. Then we're going to cancel out moles of copper 2 sulfate, and we're going to figure out the grams of copper 2 sulfate that were consumed. So what goes in these empty spaces? Well, once again, because the chemical equation is already balanced, the mole ratio here is going to be 1 to 1. There's 1 mole of copper 2 sulfate consumed for every 1 mole of silver chromate that it's reacting with. So what is the molar mass of our silver chromate? We figured that out up here in this step. We said it was 331.74. What is the molar mass of copper 2 sulfate? We figured that out up here. It's 159.62. So when we put this all in our calculator, we'll take 131 divided by 331.74 times 159.62, and we're going to end up with 63.0. grams of copper 2 sulfate, it looks like, consumed. So we just figured out the mass of the copper 2 sulfate that was consumed, but this question wants us to figure out the mass of the excess reactant, or this stuff, that was left over. So if we take a look, how we're going to do that is actually quite simple. In our final step, what we need to do is take the starting mass of our excess reactant, 114 grams, and we're going to subtract the amount of our excess reactant that was consumed, 63.0 grams. Let's go ahead and rewrite that here. So we're going to subtract 63.0 grams. So to get the mass of the excess reactant that's left over, we're going to take the starting mass of our excess reactant and subtract the mass of our excess reactant that was consumed. And this should give us our final answer. When we take 114 minus 63.0, we're going to get 51 grams left over. And this here is going to be our final answer. So it says to calculate the mass of excess reactant left over from the reaction of 114 grams of copper 2 sulfate and 131 grams of silver chromate. So we had to write the correct chemical reaction equation. We then had to use the two masses that were given to us to determine an arbitrary quantity of one of these products. We ended up picking this one here. This allowed us to determine which of the reactants was limiting, which one is going to run out first in the chemical reaction, and which was in excess. That would be this one. We then use the initial amount of our limiting reactant here in this step to figure out the amount of our excess reactant that was consumed in the chemical reaction. We then subtracted the amount of excess reactant that was consumed from the starting amount of our excess reactant, and we ended up with 51 grams of copper 2 sulfate left over after these two things react with one another. So there's a lot going on in this problem. If you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.